Hello, student. Welcome to Success Spectrum Academy, where we turn learning into success. So, today we are starting an exciting journey into the chapter Motion, which is crucial not only for class 9th exam but also for IIT Foundation, NTSE, and Olympiad. So, get ready to master every concept with clarity and confidence. So, let's begin this chapter. Now you can see the concept mapping of this chapter. Okay, so have you ever wonder means what is motion or how we can define motion? Okay, so change in position is known as motion. Okay, so physical states are there are two types of physical state. Okay, so if we'll see the concept mapping of this chapter, so physical states are divided into two types. One is rest, another one is motion. Okay, rest means no change in position, and motion we can say change in position. So imagine you are sitting in a car moving on a highway. Okay, from your means we can say from your perspective inside the car, means we can say you may feel stationary. Okay, while you are traveling in a car, you are sitting inside the car, so from your perspectives you are feeling that you are stationary, you are not moving. Okay, but for someone standing outside, you are moving. So this brings us the questions what exactly the motion is. So motion is change in position with respect to the observer, or we can say reference. Understood? So now motion is divided into four categories here: uniform motion, non-uniform motion, linear motion, circulatory motion. So motion is change in position of an object with respect to the reference or observer, or with respect to we can say time also. So it can be classified as uniform motion and non-uniform motion, linear motion and circulatory motion. Uniform motion means equal distance traveled in equal interval of time, and non-uniform motion is unequal distance traveled in equal interval of time. Linear motion, straight line motion; circulatory motion, circular path. Okay, then we have two types, that is distance and displacement. So distance and displacement is related to linear motion and circulatory motion. So here distance means the actual path traveled by the object is known as distance. So total path covered by the object is known as distance. So it is an scalar quantity. But if you will see the displacement, the shortest distance between initial and final position. So this is vector quantity. Then we have speed and velocity also. So speed means distance covered per unit time. Okay, so speed formula is distance upon time, and velocity we can say displacement per unit time with direction. So with direction means velocity is vector quantity. So if we'll talk about here uniform and non-uniform motion, so non-uniform motion now divided into accelerated motion and deaccelerated motion. And here if we'll see the accelerated motion and deaccelerated motion, so accelerated motion having two types, that is uniformly accelerated motion and non-uniformly accelerated motion. Similarly, deaccelerated motion having two types, uniformly accelerated motion and non-uniformly accelerated motion. Then we are coming to the equation of motion here. So equation of motion, so first equation of motion v equal to u plus at, then second equation of motion s equal to ut plus half at square, and third equation of motion is v square equal to u square plus 2as. So here v is final velocity, u is initial velocity, and v will be the time, s will be the distance, and a will be the acceleration. Okay, so here you understood this one. Now we'll move forward. So as I told you that motion is change in position of an object with respect to reference, okay, or with respect to time also. Best thing we can write here, reference. And rest, a body is said to be in state of rest when its position does not change with respect to time. Or motion is change in position of an object with respect to time or with respect to reference. Okay. Types of motion: circulatory motion, linear motion, oscillatory motion. So what is circulatory motion? So circulatory motions will travel in circular path. Okay. And linear motion, it will move in straight path. Oscillatory motion, so it will to and fro, right? Yes or no? So it will be in the oscillation. Then what is scalar quantity and what do you mean by vector quantity? So here I can see the scalar quantity, quantity which has only magnitude but no direction, is called scalar quantity. So like distance, speed, etc. Vector quantities, quantity which having both magnitude as well as direction, is known as vector quantity, like displacement and velocity. So now we are coming to some important point here. What is distance and displacement? The actual path or length traveled is called as distance. Okay. So if you are traveling from your home to your school, okay, so from your home, you are going to your friend house. Then from you are taking that friend, again you move to another friend house. From there also you are taking that friend and you move to another friend house. And then finally you are reaching the school. Okay. So the actual path you are traveling, that will be the distance traveled by you, or that we can say distance. And this can be, suppose, 10 kilometer. That actual path you are traveling, that is 10 kilometer. But the shortest distance from home to school is 2 kilometers. So 2 kilometers is the shortest path or length traveled between initial and final position. Right? So initial and final position is known as displacement. So now you understood what is distance and displacement, the shortest path or the length traveled between initial and final position, right? So we can say is known as displacement. Displacement is a vector quantity, but distance was a scalar quantity. Displacement can be zero, okay, it can be negative or positive also, but distance is always positive. So when initial and final position are same, then displacement will be zero. Example, circular motion. So here you can see one question we have. A body travels in a semicircular path of radius 10 meter, starting its motion from point A to point B. So calculate the distance and displacement, okay, of this. So what will be the distance and displacement here? So distance and displacement. So as I told you, distance means the length of actual path traveled by object, and displacement we can say that shortest distance between the initial and final position. So total distance traveled by body, we can write total distance traveled by body is equal to S. So this we need to find out. So how we can find out? So here what is given? The pi value is given, pi equal to how much? 3.14, and r value is given, r equal to how much? Pi equal to 3.14, and r value is given 10 meter. Okay. So what is circumference of a circle? It is 2 pi r. So here the distance from A to B, right? So, it's a circle. So here s equal to pi r. So if s equal to pi, r will, right, pi is equal to 4 into r equal to 10. How much will be? 31.4 meter. So here it is 31.4 meter answer. Okay. Then this was the distance. Now we need to find out the displacement. So the displacement, we can say total displacement of the body, we can say d equal to t. This we need to calculate. Okay, so d equal to, here if we'll see, radius is given 10 meter, and from A to B this distance is 2 into r, the diameter. So 2 into r means 2 into 10, this will be 20 meter. This will be the another answer, and this is displacement, and here distance. So in this way we can calculate distance and displacement. See, so here next example, a body travels 4 kilometer towards north, then he turns to his right and travels another 4 kilometer before coming to rest. Calculate total distance traveled, okay, and total displacement. Okay, so total distance traveled and total displacement we need to calculate. So total distance traveled, if you'll see, means the total distance traveled by the body. So here you can see in this question it is given the body is traveling towards north. Okay, so total distance traveled and total displacement we need to measure. So here you can see this. Okay, so the body is starting from here and it goes to 4 kilometer in this side. Okay, suppose towards north, then move towards right. Okay, this will be another 4 kilometer. Okay, so total distance traveled. Okay, so we will name it here. Okay, this will be the O, position O we can say. Another position we have, okay, A, and another position we can say B. Okay, so here this position is A and this position is B. Okay, and we will join this as well, okay, for later. So total distance traveled means here at point B the body comes to rest. Okay, so 4 kilometer plus 4 kilometer will be the total distance. Okay, so total distance equal to OA plus AB. So it's moving towards north. Okay, then towards right again 4 kilometer. So 4 kilometer plus 4 kilometer, total 8 kilometer will be the answer. Okay, so here 8 kilometers the distance or total distance covered by the body. So what will be the displacement then? So how we can calculate the displacement? So displacement will be the shortest distance from O to B. Okay, so here I can see this is a triangle we can say. So the displacement will be equal to OB, and OB we have hypotenuse of this triangle, and OB equal to the root of OA square plus AB square. So what is OA square? That is 4 and 4, so 16. So here it is 4 and 4. So 4 square plus 4 square under root. So here it is under root 4 square plus 4 square. So this will 1632 means under root 32 is equal to how much? So we know that square of 5 equal to 25. Okay, so means, and square of 6 equal to 36. So the square of 32 means it is in between 5 and 6, more than 5.5 also, right? It's not in between exactly, not, it is in between 36 and 25. So it will be around 5 point something. Okay, so we can calculate this. So after calculation what we'll get? So here we'll get 5.65 kilometer. This will be the another answer. So we got the distance and displacement. Now next is here uniform motion. So here you can see this, right? We did this question. Now coming to next topic, uniform motion. So when a body travels equal distance in equal interval of time, then the motion is said to be uniform motion. Okay, so here you can see this means S and T. both are means equal interval of time. Okay, so with respect to time, if we'll see, so body travels equal distance in equal interval of time, then it is uniform motion. So here I can see the graph. Then non-uniform motion, when a body covers unequal distance in equal interval of time, then the motion is said to be non-uniform motion. So here I can see the graph we have. Okay, S and T. So here it is increases, time increases, right? Yes, no, then S and T here also if we'll see. Okay, so this part means we have decreases. So non-uniform motion having two type. One is accelerated motion. So when motion of body increases with time, it is accelerated motion, and deaccelerated motion when motion of body decreases with time is known as deaccelerated motion. Now, next you can see here speed. Okay, so the previous part we did here accelerated motion, deaccelerated motion. Now we have speed. Okay, so we know that speed equal to distance traveled upon time taken, or simply we can write this as v equal to s upon t, and SI unit of speed is meter per second here. So SI unit of speed is meter per second. Uniform motion, if it is uniform motion, then speed will be constant, and if it is non-uniform motion, then speed will varies or speed will not remain constant. Hence we can consider the concept of average speed for non-uniform motion. So what is average speed formula? Total distance traveled upon total time taken. So here we can see this is total distance traveled upon total time taken. Now see one question we have, what will be the speed of body in meter per second and kilometer per hour if it travels 40 kilometers in 5 hours? Okay, so the body is traveling 40 kilometer in 5 hours. So distance is given 40 kilometer and time is given 5 hours. So speed in kilometer per hour we need to find out. Okay, so what is formula for speed? Total distance upon total time. So here we'll write the given thing, distance equal to 40 kilometer and time equal to 5 hours. Given distance equal to 40 kilometer and time is given 5 hours. So first we'll measure distance in kilometer per hour. So what is the formula for speed? So speed to distance traveled over total distance upon time. So what is distance? 40 upon 5. So yes, 8 kilometer per hour. Okay, so 8 kilometer per hour, the total distance traveled in kilometer per hour. So this will be the answer. So here speed equal to distance upon time. So 40 upon 5, we are getting 8 kilometer per hour. Okay, now we can measure the distance in meter per second. So directly we can convert the kilometer per hour to meter per second, but we can measure this. So distance is given 40 kilometers. So 40 kilometer per 40 kilometers means 40 into 1000. So it will be 40,000 meter and 5 hours. So 5 into 60 into 36 into 5 we can say. So 36 into 5, okay, or directly we can write it as it is only 5 into 60 into 60. Okay, so that will be easier for calculation. So again the speed equal to the distance 40,000 upon 5 into 60 into 60, only cancel. Okay, 5, 80. Okay, so 80 upon 36. So if it is 80 upon 36 means 36 2s are 2.22 meter per second. Or we can use the concept for means conversion factor we can use directly 8 kilometer per hour, that also we can convert into meter per second. Or directly we can change the answer only. So here 8 kilometer per hour. So 8 kilometer per hour means here it is 8 into 1000 upon 3600. So 0000 cancel 10. So 8 into 5 upon 18 if we'll do. So this will be also means 40 upon 18 approx, and we'll get 2.22 meter per second. Okay, so in this way also means directly if we'll multiply this conversion factor means here it is 5 upon 18. Okay, so kilometer per hour will convert it to meter per second directly. So next you can see here velocity. So it is the speed of a body in a given direction. So velocity is a vector quantity and its value changes when either magnitude or direction changes. So velocity formula is displacement upon time. So as we know, displacement is also vector quantity. So velocity can be negative, positive or zero. So displacement also it will be negative, positive or zero. Okay. So displacement per unit time with direction is known as velocity. So for non-uniform motion, average velocity will be calculated in the same way as we done in the average speed. So average velocity equal to total displacement upon time taken. Okay. Then for uniformly changing velocity, the average velocity will be here. Okay. Or it will be calculated as, can be calculated as average velocity equal to initial velocity plus final velocity upon 2, or average velocity we can write here u plus v by 2, and we know that velocity can be negative, positive or 0. Then we have a question here. During first half of a journey by a body, it travels with a speed of 40 kilometer per hour, and in the next half it travels with the speed of 20 kilometer per hour. Calculate the average speed of the whole journey. So how we can calculate it? Which formula we can use here? So here you can see this. What is given here? Okay, means during the first half of the journey. So we can write V1. Okay, so V1 equal to how much? 40 kilometer per hour. Okay, and second half of the journey V2 equal to how much? 20 kilometer per hour. Okay, so what will be the average velocity here, or average speed we can say? So average velocity we can say here v1 plus v2 divided by 2. So average speed equal to v1 plus v2 divided by 2. So here it is 40 plus 20 divided by 2. So 60 upon 2, it will be 30 kilometer per hour. Okay, this will be the answer. So we got the answer 30 kilometer per hour. So next question here we have a car travels, okay, 20 kilometer in first hour, okay, and then 40 kilometer in second hour and 30 kilometer in third hour. So calculate the average speed of the car. So a car travels 20 kilometer in first hour, 40 kilometer in second hour and 30 kilometer in third hour. Calculate the average speed of the car. Okay, so speed in first hour, so 20 kilometer per hour. So distance traveled during first hour equal to what? 20 kilometer. Okay, so here we can write it for first hour. So distance traveled equal to what? 20 into 1. So it will be 20 kilometer only. Okay. For second hour, distance equal to, again here 20 meter in first hour, 40 meter in second hour. So 40 meter in second, again 40 will be 40 meter. Okay, then third hour, the distance equal to 30 meter. So 30 into 1, 30 kilometer again. So if we need to find out average speed here, so average speed equal to what? That is v1 plus v2 plus v3 divided by 3. Okay, this total distance traveled upon time taken. So average speed equal to how much? Total distance traveled upon time taken. So here total distance traveled means 20 plus 40 plus 30. Okay, so here we'll write total distance traveled upon time taken. So average speed equal to total distance upon time taken. So now here we can write this as, what is total distance we have? 20, 40 and 30. So we'll add all three. So 20 plus 30 plus 40. And what is total time? 1 plus 1 plus 1, 3 hour. Okay. So now this 40 plus 20 equal to 60. Okay. And plus 30, 90 upon 3. So this will be 30 kilometer per hour will be the average speed now. This will be the answer. So that's it for the today's session on motion. Okay, this is the part 1 of the video. Okay, so part 2 will coming or will be coming soon. Okay, so from here onward, we'll discuss the acceleration and all, right? Yes or no? So this is the first half. So if you found this video helpful, please like, share, and subscribe to Success Spectrum Academy for more such content. And don't forget to hit the bell icon, okay, to stay updated. Keep learning and keep growing. See you in the next video. Okay. Thank you for watching.